Okay, let's thank Alyssa. So, any questions?
Can you explain your other two terms in your Hamiltonian? Off-diagonal. And how did you choose the coefficients on those elements? Parameters?
Okay, so well, I did not choose it. That's I think something that remained constant between all of them. No, I cannot. I'm sorry.
Let's skip values of this constants and discuss just the operator part with this cat and brat. In green and in your blue highlighted things, the brand cat terms have different indices. What does it symbolize?
Oh, it's the transition between the initial energy state and the excited energy state. So just the energy transition between the two of them.
Mm-hmm.
And then the other one is the relaxation.
Or is transition between what?
3 and 2?
Yeah.
Yeah.
Britain? Partially satisfied? Okay.
So can you return back to your movie? So for the, I guess, my understanding is that at higher temperature, so it means this other, on the
one on
left side, right? So you excite to the highest parabola, or not parabola, whatever it is.
So in all of them, they're excited to the same point. And between these two, you can see that they're excited.
But you start your initial, right? Packet starts in the highest potential.
Yes.
Then it reaches a point where the both green lines coincide.
Are you talking about like this point right here?
Yeah, or it goes slow for the second case, doesn't matter, right?
Yeah.
So, and then what happens with the packet after it's reaching this crossing point? Because, I mean, movie was...
So it splits, basically.
Mm-hmm.
Splits?
Yeah.
Is it splits like 50%, or you have
I did not
more
do the
there, more there,
integrations,
how
but
it changes with
visually,
temperature?
It does look like it's, that's like why I, visually it does look like it's about 50-50.
Mm-hmm.
I did not do the integrations for it, but just looking at it, it does. That's why we did the, I was confused on that. That's why we did this one here. Which
And this is for higher temperature, right?
Yeah, it's not exactly the same, but it coincides with this one. So by oscillating it in the beginning, the ratios change, and that's why we did the, like letting it feel the temperature.
Yeah, so if you change the conditions, then the splitting of the packet goes
Yes.
with, so more goes down and less
More
stays
goes
on the
up.
higher.
Because of the
More goes up?
Yeah, more goes up because of the higher energy available.
Okay. Oh, yeah, temperature. Okay.
Yeah. So, I mean, it still looks approximately equal, and I'd have to do the integrations to tell, but it definitely does look like there's a significant more on the upper range than there was previously. It's just distributed.
Okay. Interesting. Thanks.
So you can control outcome of chemical reaction. Okay.
Just pushing a button.
Professor
So a
Hoang.
quick question. So in your simulation, the temperature goes from minus 200 centigrade to 41 or something.
Yeah.
What is the typical temperature in this town?
I think it would just depend on whatever you're doing it in. I think that they do it more like colder. I think it's frozen when you excite it. I'm not 100% sure on that, like just experimentally wise. But I would assume that it's not above room temperature, that they would probably have to like have some sort of stabilization factor, so it'd probably be pretty cold. So.
If you're not sure, I would guess what is to say liquid nitrogen.
Liquid nitrogen, so what's that, negative 70?
Nitrogen or helium?
Nitrogen is less
It would be
expensive.
less than 0, I'm assuming.
It's good to know,
Yeah.
because whatever, we can throw in whatever number for a computer to do, right? But
Yeah.
you have to think about whether it's relevant to experiments or not. So, yeah.
More questions to Alyssa? If no, let's thank her once again.
Question for Dimitri. What is the scale for